to our August live Q&A that, for confusing reasons, actually is taking place on the 1st of September, but that's just a little calendaring snafu. As you probably know, I like to do these things on a Saturday, just because it makes it easier for people to attend across a very broad range of time zones. And it's usually a day off in pretty much the whole of the world. So that works well. So I had to move it on a Saturday, and last week was too soon. This week is just perfect. So let me know, first of all, can you hear me? I'm going to wait on the chat to see some responses. It takes about 20 seconds after I say something for you to see it and type back, but I just want to check that the audio is good before we get started. Loud and clear? Great. Woohoo. All right. So as you may have noticed, I'm trying something slightly different this week. A lot of people have mentioned that I may not be the world's greatest videographer. And if you didn't know this, this show is produced by a team. So we have a director, that's me, the producer, that's me, the videographer, that's me, the audio engineer, that's me, and the on-screen talent, that's me. And I only know how to do one of those jobs well, which is answer your questions. The rest of the jobs, sometimes it's okay, sometimes it's not. Also, as you probably know, I bounce around from city to city, and I live in short-term rentals, always in a new place. I don't really have the luggage space to carry around heavy, expensive lights and really professional gear. So I have to do with kind of miniaturized gear. Every week you might see a different background, and it's usually this gray color that seems to be very popular in short-term rentals nowadays. And every week it's fairly close up to my face because most of the background is uninteresting. Well, a lot of people commented on that. Actually, my team also commented on it recently because they said they couldn't fit captions into the videos because when they printed the captions, they ended up right here because the video was so zoomed in. So I'm doing something different, taking a step back a bit. Now, you've got some weird elements. You're probably thinking, is this the special Moose Q&A? What's up with the flowers? Why is there a door behind me? Am I just trying to exit quickly in case somebody shows up? Well, basically, this is what I have here, this particular Airbnb. I'm trying to add a bit more color to the background, so it's not always this boring gray. Give a bit of a wider perspective. What I do like about this setup, and you can tell me if it sucks or not, I'm sure you will, is being Greek, half of my talking is with my hands. And at this angle, you can really see my hands. So that works, I think. I think that works quite well. All right. So let's see how the chat room is responding to my new videography. They like the flowers. They like the moose. I think this is a success. I think what we can do is take this out to the broader YouTube audience, because I guarantee you, whenever I take anything to YouTube, there are at least a dozen people who will shit all over it. So we're going to get some people complaining that there's too many flowers, or why is there a moose? The moose and flowers. Yeah, exactly. You got it, Camille. That's exactly what's going to happen. All right. But enough about that. We're going to get to the questions in just a second. Let's see. Oh, a few things about the questions before we get started. Again, this is mostly background, and I want to talk to you and thank you for participating in the Q&A this week. We got lots of great questions this week, and thank you for commenting and thank you for voting. If I can please ask, it's really important that you ask questions and vote so that you can signal which questions are the ones you want to be answered, like really, really want to be answered. And that way I can tell the difference. Now, if I have a lot of questions at the same score, I'm going to pick the ones that I think are going to make for a more interesting video, or the ones that I haven't been asked before, or the ones that I think are a better fit for my audience, which is mostly people who are beginning their journey on cryptocurrencies, always beginners. So one of the things I do want to point out, though, this month I did get a couple of questions that were, how do I put this? They were about people, and more importantly, drama between people. So-and-so said that this company is trying to hijack this, and then the other guy said that this other thing was happening, and so believes that they should be doing this, and Twitter banned this guy, and what do you think? Bottom line is I don't do drama, and I really am not interested in playing this kind of horse race popularity contest. Who said what? Why did they say that? Is there a conspiracy? Is this person trying? I'm not interested in that. I'm interested in this technology, and if this technology could be swayed by people and easily manipulated by people, then we're not doing it right. I think it can't be swayed by people. Sure, people can push the price around in the short term, and people can manipulate the news and make propaganda about it. But in the long term, if you really believe in the idea that a system of trust, whether that's in the form of money like Bitcoin, or if it's other platforms, blockchains, platforms of trust, that is open and borderless and neutral, works for everyone, and delivers something unique that you can't do with a centralized solution, that you can't do if you manipulate it with people and personalities and popularity contests. If you truly believe that it's simply better technology, then none of this matters. All of this drama is just short-term noise, and it doesn't matter. That's my perspective. So I'm not going to play the drama, and that means that even if you ask me a question about all of this drama, and even if it's highly voted, I'm not going to answer it. So I deleted 2 questions, unfortunately, this month, because I'm not going to play the drama game, and I'm not interested in answering those particular questions. I hope that's okay with you. It's okay with me. All right. Note to self. Next time, use some Windex on the back of this, because it's got a lot of finger marks. We got to fix this, people. Don't worry. All of this is going to be cut in the edit. This is really about my Patreon subscribers and supporters. Thank you so much for all of the support that you give me, and all of the love, and all of the confidence, and of course, for your subscription on Patreon, which has allowed me to build up my team and do more and more and more to spread this important information and to get this education out to as many people as possible in as many languages as possible. Last week, I made an announcement about a project that's been in the works for more than 4 months now, and my team has been working very, very hard. And the project was a big donation of free books that was donated to high school hacking organizations driven by a company called, or an organization called Hack Club. And what Hack Club does is it helps students organize their own hackathons and computer science clubs within high schools, and then supports them with various monetary resources, but as well text resources and things like that. So let me tell you a bit about how this project came about. And don't worry, we're going to run a bit long on the Q&A, but it's worth it. I want to tell you a bit about the things that you've been able to do with your Patreon support, and what we're doing with it. So this year, I've hired 2 people to help me with various projects, including spreading education. And one of those projects is getting more of these books translated in more languages, as well as getting them distributed more broadly. one of the really big targets for me is South America, and another really big target for me is Southeast Asia. These are places where it's difficult to get Amazon. And yet my books are primarily distributed by Amazon. Independent bookstores and distributors can buy them and distribute them, but it's very difficult to get into those channels. So we're trying harder. So our first idea was, why don't we send free copies to libraries, community libraries, city libraries, university libraries, et cetera, so that they can put them on the shelves and make them available to their students and readers and library patrons. Great idea, right? Doesn't actually work. So we got this hilarious result where I sent books, and then I got letters back from libraries, and they said, thank you so much for donating the books. We have too many books. So we're selling your books in our local store. We've donated them to a bookstore to sell so that we can use the proceeds to support our library, which in a way supports the library, which is great. I want to support community libraries. But that means they didn't actually make those books available to their readers, their patrons. They simply sold them to one individual who took them home and kept the money and funded library activities. I should have seen this coming. Obviously, libraries want to choose their own books. And so that project was a mess. So we changed tack. And we collaborated with Hack Club, which is a fantastic organization. It's student-led. And its target is high schools, which is an even better audience for beginners in this space. And so we made an agreement, and as a first run, we are distributing 247 books to hack clubs, not just in the US, but in the US, Europe, India, and South America. And that's just the first wave. Those books have already shipped. And they're reaching destinations now just in time for the beginning of the school year. We're very excited about this collaboration. And what we'd like to do is see how it goes, and if it's successful, expand that out. As I talked about that on Twitter and told everyone about these wonderful contributions, I got a contact from Colombia where they asked me to ship 600 copies of Internet del Dinero so they could distribute to people attending a conference. And this is exactly the kind of thing we want to do, especially for Spanish-speaking countries where it's difficult to buy books from Amazon, and especially for South America, where we now know there's all of these currency crises. All right. Are you sick of hearing me talk about all of the wonderful things you're doing with your Patreon support? And do you really want me to go to the questions? Yeah, I think so. All right, let's do that. We're going straight to the questions. Jun asks, Andreas, I submitted a small transaction to send BTC to another address, and it has been pending for over a week now. I was testing to see if I would be able to send a transaction for the lowest fee of 1 Satoshi per byte. I'm afraid the transaction is stuck and cannot be double spent with a higher fee because the wallet gives me an error that it's in the mempool. Is there anything I can do to cancel my transaction on my end, or will I have to wait until it drops off the mempool in order to resend it with a higher fee? Thank you, Andreas. All right, Jun, great question. This is a really important question that affects a lot of beginners in Bitcoin. And really what you're experiencing is a combination of a mempool that is a marketplace for transactions, where if you want your transaction prioritized, you're competing against others, and your own wallet, which may have certain policies and approaches to how it does transactions that may not be ideal. So, first of all, is it possible to send a 1 Satoshi per byte fee? Absolutely. Every single transaction I do, I pay 1 Satoshi per byte. I haven't paid more than 1 Satoshi per byte, I think, since February. So it is absolutely possible to send with 1 Satoshi per byte. And those transactions do get confirmed. However, in order to do that, I'm using a wallet that gives me options for managing the narrow cases which happen. 1 in 10 transactions, I'll have a problem where it gets stuck, just like you've experienced here. And when that happens, my wallet gives me 2 ways to unstick that transaction. The first one is called replace by fee, which means that my initial transaction is marked as RBF, meaning it is able to be replaced by a transaction spending a higher fee. It's not the final version of that transaction, if you like, and there may be subsequent transactions that spend it with a higher fee. Now, by doing that, really that's just an extra signal to the miners, because the miners can choose to take a double spent higher fee transaction if your wallet can create it, regardless of whether you say it's replaced by fee or not. Because miners will always use an algorithm that maximizes their profit. So if they have 2 transactions and one of them is a double spend of a previous transaction with a higher fee and that first transaction hasn't been confirmed, they'll take the higher fee. It doesn't matter if you're signaling RBF or not. Although some miners will look for RBF transactions, and the algorithm will treat them favorably if there's a replacement transaction. Really what that's about is your wallet knowing how to manage that double spend situation. So that's one technique, replace by fee. The other technique is called child pays for parent. And again, this is not like a magical feature that's instructing the miners what to do. It's simply recognizing that miners will always maximize their profit and take the transaction or chain of transactions with the highest fee. Child pays for parent says, my first transaction doesn't have enough fee per byte to confirm. What I'm going to do is chain a second child transaction that depends on spending the first one with a higher fee. And what miners will do in their algorithm that selects transactions from the mempool is they don't look at how many satoshis per byte in each transaction. Instead, they look at how many satoshis per byte in each chain of unconfirmed transactions. So if you have a parent and a child, their total satoshis of fees are divided by the total bytes so that the miner can make a determination in their best interest that if they confirm both of them together, they can get a better satoshi per byte rate than if they don't confirm the first one because you can't confirm the second one. So child pays for parent, again, is a technique used by the wallet that recognizes that miners' transaction selection algorithms will be based on maximizing their profit. The wallets I use, Samurai, Electrum, for example, tend to support these capabilities and allow me to do that. You can actually construct a child pays for parent transaction if you construct it manually, if your wallet isn't allowing it. So back to your question, Jen. You said you're afraid the transaction is stuck and cannot be double spent with a higher fee because the wallet gives me an error that it's in the mempool. That doesn't mean it cannot be spent by a higher fee. That means your wallet is refusing to do it. If you manually construct a double spend transaction with a higher fee using another wallet, for example, that supports that, it will go through, and you'll be able to nudge that transaction through the mempool. So the way I do transactions is I always start with the absolute lowest fee possible. I mark the transaction as replaced by fee. I let it sit in the mempool. If it's urgent, for example, if I have a 15-minute window because I'm doing a retail transaction, I'm going to check on it and see how it's sitting in the mempool, and I might bump it immediately if I see that I miscalculated the fee. But if it's not urgent and I have, a day, like, for example, today is the 1st of September. I'm about to run payroll, and payroll is, in my company, is Bitcoin. So I'm about to do a whole bunch of transactions. In fact, they're multi-recipient transactions where I pay my staff in Bitcoin. And those are transactions where, quite honestly, they don't need to get it in the next 15 minutes. As long as it goes through today or early tomorrow, it's good enough. So that means I have a 144 block window to get them through, which means I don't need to worry about the fee. 1 Satoshi per byte will work. If, by some weird coincidence, the moment I decide to do that, there is a massive rally or the mempool gets absolutely chock full of transactions, I might have to bump it. So I'm going to replace by fee. I'm also going to use child pays for parent, which sometimes works faster to confirm that transaction and to get my payroll through. All right, let's check on the chat room, see if we have any questions. Great. Let's see. All right, Richard is asking a slightly cheeky question. Do you think building smart contract functionality on Bitcoin can make Vitalik blush? And the full question is, the ERC20 standard for creating tokens has been hugely successful, driving many individuals and businesses to Ethereum. Are you aware of any smart contract protocols allowing the creation of tokens that can be secured to Bitcoin's blockchain? More precisely, now that the Lightning Network layer is taking roots, could this be built upon to offer decentralized permissionless token issuance, combining Bitcoin's ultra-high security with Lightning's ultra-low transaction smart contract execution costs? So, Richard, first of all, I don't think Vitalik's going to blush if Bitcoin does smart contracts because, as I've said many times in the past, I don't think that Ethereum and Bitcoin are competing directly, nor do I think that they can compete directly because the flexibility that exists in Ethereum makes it less suitable for doing the robust reserve currency functions of Bitcoin. And the robust reserve currency functions of Bitcoin make it less suitable for doing the flexible smart contracts of Ethereum. You can't get both. Now, I know you're going to hear a lot of people tell you, you can absolutely get both. Bitcoin maximalists will tell you Bitcoin can do everything that Ethereum can do, only better. Ethereum maximalists will tell you Ethereum can do everything Bitcoin can do. In fact, every other chain can do, only better. I don't think that's the case. I think there are, in practice, engineering trade-offs that have to be made where you can't get everything. When I used to be a consultant, I used to tell my clients, you can get best, you can get fast, or you can get cheap. You pick two of those. So of the best, fast, and cheap, you only get to pick two. It's either going to be cheap and fast, and it's not going to be my best work. It's going to be best and fast, and it's not going to be cheap. Or it's going to be cheap and best, and it's going to take a long time to do. Those are the options. In computer science and in other terms, we call that a trilemma. It's like a dilemma, only with three. A trilemma, in which you can only pick two. Blockchains have a lot of trilemmas in them. And these trilemmas are optimizations. Security, scalability, privacy, pick two. Flexibility for smart contracts, immutability of the chain, robust finality on the consensus algorithm, pick two. Generally, these become the trilemmas that we have to optimize for. So there are companies trying to find a way to reconcile some of these and optimize for different points in that trilemma. And you can fudge a bit and move a bit in one direction, move a bit in the other direction, but you're not really removing the trade-off. In fact, I actually like systems that explicitly take a position on this trilemma and don't try to do everything. The systems that try to do everything suck at everything. The systems that have a specific philosophy. Bitcoin isn't trying to do very flexible, very complicated smart contracts because that comes at a security cost. And Ethereum isn't trying to work conservatively and slowly because moving fast and breaking things and innovating as quickly as possible to do flexible smart contracts is absolutely the sweet spot for that blockchain. And we can go into analysis of other blockchains and look at the various optimizations they do. We used to have ICO-capable ERC token-like tokenization systems in Bitcoin before Ethereum came along. And Bitcoin did this. It did it with Counterparty, which is a second-layer protocol using the op-return data parameter in the Bitcoin script to track metadata, colored coins. We had and have still the Omni protocol layer. Counterparty and Omni still exist on Bitcoin. You can still do ICOs and tokens and coins and all of that stuff. And of course, there's RSK, which is trying to build a sidechain or drive chain in this particular case that works in parallel with Bitcoin, where you have smart contracts that are pegged to the Bitcoin currency and use part of the Bitcoin security model. Again, these are different optimizations. The market is already telling us that they would rather take the flexibility of Ethereum. And quite honestly, that's a bit of a double-edged sword because, yes, you get all of the ICOs, but you also get all of the scam ICOs. So do we really want that to come back to Bitcoin? If you look at the history in 2012, ICOs and new coins and these kind of ventures were being done with alt chains. So people built entire blockchains by forking the Bitcoin code. And that's what you saw the early coins, right? Some of them made sense, some of them didn't, most of them didn't. Then we had the second layer stuff. In 2013 and 2014, we had Counterparty and Omni, and we saw a lot of initial coin offerings on those. ICOs were not invented by Ethereum. Bitcoin was doing them for 2 years before Ethereum came on the scene. And then finally, Ethereum made that so easy to do that any programmer with basic JavaScript experience can code probably an insecure token and make a mess. And so that's what's happened. I don't know that we want that in Bitcoin because that just dilutes the value proposition of Bitcoin. It's an interesting proposition. What Rootstock is doing is an interesting proposition, but we'll see how that plays out. All right, back to the chat room. Okay, say something. Is anybody still paying attention? Do you like the answers and the questions I'm selecting? Are you having fun? Can you hear me still? Are we online? Everybody's gone quiet. I'm going to drink from my mug, which has cats all over it. So this is the cat, moose, and flower Q&A. Great. All right, people are having fun. Moving on. Okay, this one's going to be a bit controversial, but I'll tackle it anyway. Sesame asks, how does a proposal fail to proceed after having majority support from miners? I'm studying the events of SegWit2x, and I'm having trouble consolidating in my mind how SegWit2x failed to proceed on a technical level. People often cite SegWit2x as an example of how users running full nodes can keep miners in check. I hope to gain a better understanding of how exactly that works with this question. I understand that more than 80% of miners signaled in support of SegWit2x as per BIP8 and BIP9. But what is the mechanism by which this proposal failed? Was the proposal never locked in because of an insufficient percentage of blocks with a bit set were mined during the difficulty retargeting period? What role did the users running full nodes play during SegWit2x to resist such a change? So if you don't remember all of this, this is from the deep, deep history of Bitcoin, which means 18 months ago. And this is the scaling debate. And during the scaling debate, especially during the summer of last year, we saw everything come to a head. Starting in the spring, a number of proposals were made on how to solve the scaling debate. And different groups within Bitcoin positioned different proposals, including SegWit2x, which was a proposal to simultaneously implement SegWit and an increase of the base block size to 2 megabytes, which effectively would have increased the base block size to 16 megabyte because SegWit would multiply that by another factor of 4 almost. So that was one proposal. And then SegWit, which was due for activation and was being activated by a new technique called BIP9, which is a mechanism for signaling using a binary field within the header of the Coinbase transaction. And there was a previous system called BIP8 that was partially used in this whole debate. And then there was a lot of flag waving. Let me explain what I mean by that. Miners have the ability in the Coinbase to put some text that signals their intent. And this isn't basically part of the protocol itself. It's like waving a flag, right? It's like putting a bumper sticker on your car. It doesn't change how the car operates. It just tells people around you what your particular position on an issue is. So let me clarify for you, Sesame Meow. You said you understood that more than 80% of miners signaled in support of SegWit 2x as per BIP8 and BIP9. They didn't, in fact. There was no BIP8, BIP9 proposal for that. What was happening was that within the Coinbase transaction, people had the bumper sticker that said SegWit 2x. But they weren't committed to switching over the software in order to run a version that would actually activate that change. So in that way, we've got to look at the difference between signaling that doesn't have a material impact on the protocol, which is cheap to do because all you're doing, a bumper sticker doesn't cost you anything. You're not putting money on the line. You're not changing what you're doing. You're simply putting a bumper sticker versus committing in the protocol under a specific software package to run a specific set of consensus rules by a specific date. So the reason that proposal didn't garner enough support was because there was enough resistance from groups that were not miners. So consensus is made by multiple constituencies. There's economic interest, which includes exchanges. So exchanges get to have some power because if they decide to list or not list one of the forks, that gives them control over what their users do. And exchanges run nodes and they run infrastructure through which an enormous number of transactions happen, as well as an enormous number of transactions that happen off-chain on the exchange's own databases, internal payments between users, etc. And again, the exchanges have a lot of control over that. Merchant processing services that process and convert Bitcoin to fiat for merchants who don't want to hold Bitcoin, or that simply aggregate Bitcoin and offer various e-commerce facilities like carts and integration with WordPress, WooCommerce, stuff like that. They have power in the system. You have the big investors who are trading, and they have power in the system by deciding what they're going to buy and sell and whether they're going to short or long various forks. And then you have the users, and some of those users may also be running full nodes, and they decide which blocks and transactions they're going to forward by choosing which software they run. So in this particular case, these economic interests were diverging. And as a result, miners didn't have, in this particular case, the confidence to move ahead and force that change on the network because they anticipated that they wouldn't necessarily have enough support. At the same time, there was a big movement called user-activated soft fork that basically had users using their nodes to impose an embargo on miners that didn't activate SegWit by August 1st of 2017. And, that had some influence too. So the reason the proposal failed to proceed was because it never had in-protocol support with software nodes to a level where it could fork the original implementation. And keep in mind, 2x, the 2x part of SegWit 2x, would be a hard fork. It would require a non-backwards compatible change that broke consensus. whereas SegWit itself was not a hard fork, it was a soft fork. In the end, the miners decided to drop the SegWit part, do the hard fork, and do just the 2 megabyte hard fork in the form of Bitcoin Cash instead of doing both SegWit and 2x. So the miners did proceed. They proceeded to fork Bitcoin Cash, and Bitcoin got SegWit, and Bitcoin Cash got its base block increase with a hard fork. They decided explicitly not to put the SegWit component in Bitcoin Cash. So that's how it played out. This is a complex balance of economic interests, and these are huge economic interests. You take a vote against consensus, you have to be willing to risk your investment. And in the case of miners, you've got this enormous infrastructure investment. And that infrastructure investment in any existing Bitcoin or Bitcoin Cash or other coins they have or other forks they have could be affected by those decisions in a way that costs millions of dollars. In fact, we're beginning to see that some of these decisions did have an impact in the hundreds of millions of dollars for some of the miners. So it's not as simple as it appears at first glance. Next up, compressed versus uncompressed keys and validation of uncompressed keys. Michael asks, in mastering Bitcoin, you mentioned that if a hash used in the pay-to-witness public key hash came from an uncompressed public key, it may be unspendable and you may lose funds in the plan's future soft fork. So part of the problem there, Michael, is that pay-to-witness public key hash, which is the SegWit version of pay-to-public key hash, the standard transaction, the SegWit version of a standard payment transaction, does not support uncompressed public keys. And that's because those have been obsolete since 2013. And therefore, carrying them forward into SegWit is a waste of space and optimization. And it's also unnecessary because they're barely used. Michael's second part of the question is, how can we determine if a Coinbase account, for example, that we send funds to from, say, a Ledger wallet that has a SegWit, was a compressed or uncompressed public key and therefore will be valid going forward? Okay, so as a practical matter, Coinbase SegWit addresses are not pay-to-witness public key hash. They're actually pay-to-witness public key hash wrapped in pay-to-script hash. And if Coinbase created these witness addresses in a way that potentially made them unspendable in the future, that would represent an enormous risk to them. Because keep in mind, the moment you send funds into a Bitcoin address given to you by Coinbase, or any exchange really, they almost immediately sweep that money and stick it into cold storage. They don't just leave it in the address you sent it. Check it out. Next time you do a transaction where you send money to an exchange or a merchant processing or a retailer or something like that, watch the blockchain and see what happens. Less than an hour after you do your transaction, that money is going to move again. And it's going to move to another address. Maybe you'll see it consolidate with some other things, jump a few hops, and then stop at an address that has a lot of Bitcoin in it. That's cold storage. And so essentially, whatever address they gave you, they're only using it temporarily so they can then move the funds elsewhere. And they're going to make sure that they can move those funds. So if they've implemented SegWit, which they have, you can rest assured that if they did their job well, they implemented SegWit in a way that only used compressed public keys. And that's determined by them. That's encoded inside the 3 address. The 3 address itself, when it's constructed, is constructed based on the underlying public key. And you can be sure they put a compressed one in there because otherwise that would violate the SegWit standard and they stand a chance to lose their money. So it doesn't matter what your wallet is doing. One of the really important characteristics of Bitcoin, this is critical to understand, is that the recipient decides how to construct an address and what that address means in terms of how it will be spent. And this is magical because it means that behind the address, you could have a private key, you could have a multisig, you could have a witness multisig, you could have a witness private key, you could have a complex script with 15 steps. It could be a lightning channel. None of that matters because all of it's going to be encoded in an address. Your wallet will send to that address. That address is hiding behind it a script, and that script is determined by the recipient. The flexibility of the recipient being able to choose how they receive and what is going to be required for them to spend it actually gives a lot of flexibility to the entire system, because that way wallets don't need to know what the recipient intends to do, what their internal governance structure or key management structure is. They just pay to a hash, which is effectively what a 3 address or a SegWit address is. And then it's the recipient's responsibility to give the right hash to them. So don't worry. As long as you are using the address that the recipient sent you, it's their problem to make sure that that's spendable. And if it's an exchange, arguably there is some risk that they make a mistake and there's a bug and they mess it up, which is always a risk. That's a risk with custodial wallets. If you're giving them money, you are trusting them. And among other things, you're trusting them to do the implementation correctly. And let me clarify, Coinbase is implementing SegWit correctly. So you don't need to worry about that. You can verify that by the fact that they execute the transactions and sweep that money very, very quickly. But in general, you are right. They could have a bug in how they implement it, and that represents the custodial risk. Back to the chat room. Let's see how things are going. Great. Camilo is asking, are these crypto cats? These are not crypto kitties. I cannot afford crypto kitties. I can only afford porcelain coffee mug kitties. Actually, I can't. This is just the mug they have at the Airbnb. I thought it would be cute to use this one as my coffee mug on camera. So cheers to you. All right, moving on. Bitcoin days destroyed. Grinners asks, Bitcoin days destroyed is calculated by taking the number of Bitcoins and multiplying by the number of days that it has been since those coins were last spent. What is the significance of this? What does this actually tell us? Well, what it tells us is it gives us an idea of maturity of coins, which means it gives us an idea of how often coins are moved and in how big amounts they are moved. So you can either look at somebody moving 1 Bitcoin after 100 days is equivalent-ish to someone moving 100 Bitcoin after just 1 day of it sitting somewhere. And so that's Bitcoin days destroyed. It's the amount of Bitcoin multiplied by the number of days that that amount has been sitting in the same UTXO. And it gives you an idea of kind of the velocity of the network. So velocity in economic terms is the volume of money moving on some time factor. So how much money is circulating in the economy. So I leave this place, I take a taxi, I give the taxi driver, let's say, $20, and they stop at the gas station and they pay $20 to the gas station. And then somebody buys a cup of coffee and something else, and they get change and they get that $20 back. And then they go and buy a muffin and they pay with that and they get some change. And then the next the end of the day, the muffin company pays its employees and gives them one of the 20. So that 20 has now moved 6 times in a day. And the important thing to recognize is that while it's 1 unit of $20, it has participated in in $120 worth of economic activity overall by changing hands rapidly. So in Bitcoin, in order to be able to get an appreciation for velocity of the economy, we use the metric of Bitcoin days destroyed because it tells us either that money is moving very soon after it stopped moving, or that very large volumes are moving, and kind of the product of those two numbers is kind of the metric. I hope that helps explain it. I think I've only really seen one place track that, which is blockchain.com. They had the chart running since the very early days. It was one of the first charts that they offered that nobody else was offering, kind of in terms of analysis of the blockchain. And I still think it's really one of the few places where you see that metric. I find it fascinating. And every now and then, you'll see a news article or someone tweeting and saying, there's a lot of money on the move. And they'll use Bitcoin days destroyed to give people an idea of the magnitude and maturity or age of the money that just moved. Next question. Gali asks, what is a Dandelion transaction relay, or BIP 156? It's expected to come within Bitcoin Core release 0.18. What will this be good for? I'm so glad you asked, Gali. This is slightly technical, but it's also fascinating, and it's a fantastic development. This is a technology proposal that was developed by a team. And unfortunately, I don't have it right in front of me right now to give them appropriate credit. But if you do a search for Bitcoin Improvement Proposal 156 or Dandelion, you'll find the people who are responsible for this. It's a fascinating idea. So let's think about this for a second. When you make a transaction on the Bitcoin network, in theory, no one can really tell where that transaction came from. From the perspective of a single node, if one of your neighbors sends you a transaction, you have no idea if that transaction is coming from them, from the wallet on that node, or they're simply relaying it from one of their neighbors and one of their neighbors and one of their neighbors, and it's traveled halfway across the internet. All transactions get to every node eventually. So once transactions injected into the network and it propagates everywhere across the network, you can't really tell where it came from. And that's great. That's a fantastic element of privacy. Now, put your naughty hat on, or your surveillance state intelligence agency hat on, and think about, what does it take to figure out where that transaction came from? And what it takes is a form of network triangulation, where basically what you do is you create all of these Bitcoin network nodes, and you strategically sprinkle them around the internet so that they are at specific important junctions and points in the routing architecture of the internet. You put some on big cloud service providers. You put them near major routing points, important mining nodes, et cetera, near in terms of the IP routing network, not in terms of geography. And then you monitor and listen from all of them. So then when a transaction appears on the network, like, oh, I heard it here, and then a few seconds later I heard it there, and then a few seconds later I heard it there, and if I triangulate based on the route, it probably came from this node. So if you have enough nodes sprinkled across the network, when that transaction appears, then you can, basically using timing and the source addresses, try to find a correlation and figure out where it came from. So you can break some of the privacy characteristics of the network by having enough nodes interspersed among the Bitcoin nodes that are doing surveillance. Now, this is very, very similar to how the government breaks anonymity on Tor. They use a very similar approach, which is inject lots of Tor networks and use them, lots of Tor nodes into the network, and use them to do surveillance in such a way that they can time specific packets going through and look for likely sources by understanding the latency and propagation characteristics of the network. All right, so here's how Dandelion works. What Dandelion does is it delays the appearance of the transaction on the network by routing it quietly first before bursting it out. So essentially, it uses a routing network where the transaction first propagates a few hops within the network without being flooded to everyone. And then once it arrives at a specific distance, it bursts out like a dandelion seed that floats through the air until it hits a certain point and then sprinkles out all of the little seeds. So the reason for that is because if you're trying to triangulate, you're going to see the point at which it burst rather than the point at which it originated. And if you have enough of the transactions being routed this way, and by including it in Bitcoin Core and as part of the core peer-to-peer network protocol, that will mean that we'll see a lot of transactions being routed through Dandelion. The moment at which the network starts flooding that transaction is removed from the moment when that transaction is injected. And by using encryption along the hops, it's much, much harder to do this surveillance by, not impossible, but much harder. So the degree of privacy is increased. It's a brilliant idea. And for the first time, I'm a curmudgeon when it comes to names of projects. Like, I think Segwit is a terrible name, for example, because the name doesn't really evoke anything and it's badly chosen and it really reflects an engineering mentality. But Dandelion, beautiful name. It immediately evokes the image of exactly how this technology is. You can explain it easily to people. The moment they hear Dandelion, they remember what it is that it does. It's so evocative. What a beautiful name for a project. Good job. All right, moving on. Some great conversation going on there. A very interesting point by Camilo that velocity of money means nothing for Austrian economics. Velocity of money as a concept that underlies value or economic value is definitely a Keynesian principle. But hey, I'm not doing the economic analysis on this one. I'm just explaining what it means. So thank you for jumping in and making that observation, Camilo. That's very interesting. All right, let's move on. So I'm going to run a bit late on this Q&A, so I hope you're going to stay with me 10 or 15 minutes past the top of the hour because I started off with some brief messages for my patrons, and I'm going to run a bit late on the Q&A. Don't worry about it. Ron asks about hardware wallet security. Let's say I use a securely protected, very long and strong passphrase with my BIP39 compliant 24-word mnemonic in my hardware wallet. Is it unsafe to publicly publish, meaning on Facebook, on Twitter, the 24-word seed, treating my passphrase as the thing that protects my assets in my hardware wallet? Short answer, Ron, it is absolutely unsafe. Long answer, let's look at why it's unsafe. So the way the BIP39 standard works is that you have 24 words, for example. It can range from 12 to 24, but most wallets have 24 words. 24 words actually encode 256 bits of entropy, which is used to produce the master the master root node for your hierarchical deterministic wallet. But basically, let's say your master key is produced from these 24 words. Now, in the process of producing that, your wallet that is BIP39 compliant will operate a password stretching algorithm. And that password stretching algorithm has only a few rounds. It's not using a lot of rounds to stretch that. By default, if you don't use a passphrase, it uses the word mnemonic as the salt in that password stretching algorithm. Think about it this way. We take the 24 words, we throw in another value, which we call the salt, which is just the text of the word mnemonic. And then we mix it up 2,000 times through a hashing algorithm that repeatedly hashes to produce another value. Now, the reason for that function, that password stretching algorithm, which is called PBKDF2, is that the password stretching ensures that it's difficult to brute force the passphrase. If you are using a passphrase on your BIP39 compliant wallet, then in order to check if that ends up as a Bitcoin address that is actually got money in it or verify it against a known address, you have to go through those rounds of hashing. And that takes time. I mean, it doesn't take a lot of time. On a powerful computer, let's say like this laptop, it takes probably less than a millisecond. On a much less powerful device like a hardware wallet, a ledger or a Trezor, a small USB device, which doesn't have enough processing capacity, it actually takes a few seconds. And so you'll notice when you enter your passphrase and you hit enter on your hardware wallet, it's going to give you a progress bar, and it takes maybe 2-3 seconds. So the reason for that is, in order to make it suitable for a small hardware device like that, they had to really limit the number of rounds of stretching. Unfortunately, that introduces a weakness, because you can implement a stretching algorithm. Not only can you implement it in a laptop 1,000 times faster than you can on a Trezor, worse, on a GPU, you can do it maybe 100,000 times faster. On an FPGA, maybe you can do it 10 million times faster. And if you used an ASIC for it, you could probably do it 100 million times faster than you can on the Trezor, which then makes it possible to try an enormous amount of passphrases. Now, if the attacker needs your 24-word seed and your passphrase, that is a good security mechanism. It means that if somebody finds your 24-word seed lying around, you shouldn't have it lying around. But if they do find it and it's not sufficiently physically secured, then brute forcing it, brute forcing the password, will require either a lot of infrastructure or a lot of time. They either need to have specialized computers, GPUs, FPGAs, ASICs, etc. Or it's going to take a long time. And by a long time, I mean that a relatively complex passphrase will keep you safe for several weeks, a month. A very strong complex passphrase will keep you safe for months, unless the person is willing to spend, let's say $1 million on hardware to break that passphrase. So there's these trade-offs, right? And at the bottom end of these trade-offs is this small hardware wallet that can't do this faster than about 1 or 2 seconds when you type it in. You don't want it to delay any more than that, because then the hardware wallet becomes difficult to use. So that's the trade-off there. So someone astutely pointed out that your passphrase effectively is a brain wallet. And we've talked about brain wallets before. Brain wallets are where you make up a phrase, you hash it lots of times, and you produce a Bitcoin address, and you use that, a Bitcoin private key and address, and you use that. Brain wallets are not secure, because absent a second factor, you can just pre-compute a very large number of very common things that people will use as brain wallets. Phrases from Star Trek, slogans from various cultural movements, quotes from movies, TV shows, poems, stories, whatever. And you can pre-compute all of that, and they will always produce the same brain wallet because there's no other factor in there. And then all you have to do is wait for someone to use that and put money into one of the Bitcoin addresses. You just track 1 trillion Bitcoin addresses, which is a simple database problem. And If someone is dumb enough to put some money in there, you just take it. And we've seen that happen again and again and again. And people use brain wallets, and the moment they put money in there, within an hour, someone's taken the money because the brain wallet they chose wasn't secure. Now, get this. Brain wallets are more secure than what you just proposed because the number of rounds used, I believe most brain wallets use 16,000 rounds, but you can configure it. You could make your brain wallet use 100,000 rounds. Is going to be far more than what a little hardware wallet can do. So brain wallets can be made more secure by more rounds, but they can never be made as secure as having a true two-factor system, which is one factor is your mnemonic, and the other factor is the passphrase, and the attacker needs both. Especially since the mnemonic itself is 256 bits of entropy, you're never brute forcing that. You would have to have either all of it or a significant chunk of it to have any meaningful way of brute forcing the rest of it in the passphrase. And then you can attack BIP39 in certain ways, but it costs a lot of money and takes a lot of time. So to summarize all of that, the most important rule in cryptography is don't roll your own crypto. Don't try to do smart things because you will make mistakes because you will not understand the impact on the complexity of solving the problem. Let me give you another classic example. I read this all the time where they say, okay, all you have to do is take your 24 words and cut it in half and store 12 words in one place and 12 words in another place. That's not the standard. And there's a reason why that's not the standard. It's not the standard because that is not secure. So next time you hear that, ask the simple question. How much less effort is it to find 1/2 of a seed? If you split it in two, and I manage to compromise one of these 12-word packs, how hard is it for me to crack the other 12 words? Is it half as difficult as 24 words? No, it's not. It's 10 to the 35 times less difficult, approximately. Why? Because what you cut in half is not the base, it's the exponent of the complexity. So you took something that had 256 bits of complexity and you converted it to 128 bits of complexity. And 128 bits of complexity isn't half of 256 bits. It's 10 with 30-some zeros after it, or 40-some zeros after it, less complex than 256 bits. Don't roll your own crypto. Don't try to get smart about trying to implement schemes and systems to split your seed, etc. You're far more likely to lose your money because you simply forgot the scheme, because it wasn't standard. Something happened to you and your heirs or your family can't get to it, or simply because you forgot a password, which we've seen again and again and again, and then you can't brute force it. Or if you go all the way to the extreme, your scheme is not as complex as you think it is, and someone can brute force it easily. You've effectively implemented a brain wallet, and your money's going to get stolen. BIP39 is very carefully balanced to achieve the best ratio of security and ease of use and backup, security and resilience, security and recoverability, and to work on smaller hardware devices. It's balanced. It's balanced by people who are actual cryptographers and know what they're doing. When you try to change the way you use it, you tip that balance. You either tip it too much towards security. I took my BIP39 seed, I cut it into 24 bits, I mixed them up, I encrypted them, I put them on Dropbox, I took that Dropbox, I then erased it from the web, and I can only access it on the archive site. Your money's gone. You lost it because you made it too complex. You buried your money in the desert without a map. Or you trade it the other way, and then you end up with something that's too easy to break because you didn't realize that what you were changing in the complexity was a big change, not a small change. Don't roll your own crypto. Unless you are an experienced cryptographer, I'll tell you, I won't do it. I don't consider myself and experienced enough cryptographer to roll my own crypto. I use the standards that are well-tested, mature, and peer-reviewed by very good cryptographers, and they work well. So write your seed down, use pen and paper, write it down, store it in a physically secure location like a locked drawer, a bank safe deposit box, etch it on steel, keep multiple copies of that seed. Use a passphrase that is strong enough that it's not easily brute forceable. 6 to 8 English words is just about right. Not English words from the mnemonic list, just English words that don't mean something, that are not a phrase, that you won't be able to find on Google, that are not written in a book or you saw in a movie. Pick 6 to 8 random words, memorize them, write them down, store them in a different location so that your family actually has a chance of getting that back. And that's going to be more secure, and you're not going to get robbed as easily. Just use the standard as it was designed. All right, back to the chat quickly. I think we're just about done with this Q&A. Anthony had a quick follow-up there. Passphrase, does that mean the password on the hardware wallet? There's two things on the hardware wallet. There's the PIN number, and the PIN number is just to protect the physical device. It has nothing to do with the seed. It's just so that if someone takes your physical hardware wallet, they can't simply unlock it. And the PIN number is designed so that if you make a mistake, it gets twice as long. The delay gets twice as long, and that quickly escalates to the point where you can only try one pin a week, and then one pin every 2 weeks, and then one pin a month, et cetera, et cetera. That's the pin. Has nothing to do with how you do the security of the actual keys. The passphrase, however, which is a long phrase that you type, which is an optional component of BIP39, is an additional security factor to your seed, and that is separate. That's separate from the PIN. That's something that in first-generation hardware wallets you would type onto your computer. In second-generation hardware wallets, you type directly onto the screen of the hardware wallet, so it's not entered on an online system. That's mixed in with your mnemonic phrase, and it affects the security of your key, and it protects your seed from theft. All right. I hope you enjoyed this Q&A. Again, thank you so much for asking great questions. I'd like to encourage you to ask more questions, to vote more often. I think my top question got maybe a dozen votes. And given that there are 1,200 patrons, we can do better. Come on, people. Pop in there. Ask the questions. Don't be shy. I love beginner questions. I love basic questions. They give me an opportunity to explain the basics, and the basics are so important. The majority of people who are going to watch these videos, the majority of people who are patrons, the majority of people who need this information are beginners just like you. And so I've already answered a lot of the technical questions. I love beginner questions. Ask your questions, comment on other people's questions, add your own thoughts, elaborate on the questions, and vote. And the better the questions are, the more they're sorted with good votes, the better these Q&A sessions can be. And now you know that I am committed to the moose, the flowers, and the kitty cats on the mug. So I'm doing my part to making these videos better. You do your part. Comment, vote, and ask questions. I'll see you in a month. Thank you so much, everyone. It's been a pleasure again. Always a lot of fun doing these. Have a wonderful weekend. If you're in the US, happy Labor Day weekend. We do it now instead of May 1st. For everyone else in the world, happy weekend. Take care.